On corrections, is there any of 25, 26, 27 you want to see done? 27. 27, yeah? Now, was again done yesterday, but we'll go one more time. I say if you have root 100 over 25, you treat both square roots separately and you can turn that into 10 over 5. That makes sense? So we're going to square root 9a squared and 100 b squared. When you square root 9a squared, you're going to get 3a. When you square root 100b squared, you're going to get 10b. And now you're doing multiplication. You want to change division into multiplication. How do we do that? Second one needs to turn upside down. And once it does that, oh sorry, not to turn the first one upside down. That's a mistake. 3a. I'm going to change it to 3aa. Everybody happy with that?
Yeah.
And 5bb. So what cancels? 3a and 3a. Divide to make 1. B and b. And then 10 divided by 5? 2. So I have 2a on top and just b on the bottom. That a cancels with that a. So 2a over b. Who got that?
Yeah.
Okay, can I have somebody taking a note of what questions I've done today? So Higgins, you write down I've done 27, just for when I'm doing it at the end of the class, okay? 27. Alright, we haven't done that one yet. Anything in 33 that needs to look at? Question 33.
5.
33 part 5. Okay, 33 part 5. It's the addition of two cubes. I'm going to change 8 into what? 2 to be cubed. And then I'm going to have an m plus 2 on the bottom. What formula am I going to use? A cubed plus b cubed equals? Okay. Okay, we're going to use that there, yeah? So it's going to turn into, what's going to turn into guys? M plus 2. A squared is? N squared. Minus AB? Minus 2n. B squared? 2 squared, which is 4. All over? M plus 2. What cancels? N squared minus 2n plus 4. Everybody happy with that? Okay, so I've done 27 and 33. Anything on 34? 34?
That's right.
Part 3. 3 over x plus 1, 2 over x plus 4. What did I ask? What's the method we use for this?
3 lines.
The 3 lines. So x plus 4 goes up to the 3, so it's 3 multiplied by x plus 4, line number 1. Line number 2, the x plus 1 goes beside there, minus 2. And finally line number 3, the bottoms go together to make x plus 1 and x plus 4. We then get 3x plus 12 minus 2x minus 2, all divided by, just keep it the same, and then 3x minus 2x plus 12 minus 2, and then x plus 1 and x plus 4. Everybody right with that?
I didn't get the bottom the same.
Did you multiply it out?
I multiplied the bottom half out.
So you got x squared plus 5x plus 4.
No, I just got x squared plus 4 and then I did the difference 2 squares on the bottom.
No. Completely left the field. If you got x squared plus, that's okay. So Rory, just put the two of them beside each other.
Yeah.
The denominators multiply by each other, and that's it. Can't do anything else.
Does that not mean you multiply them?
Huh?
If they're both in brackets?
You can, and if you do multiply them, you get x squared plus 5x plus 4. You don't get anything else.
Yeah, you don't have to multiply that.
You don't have to multiply that. Check the back of the book for an answer, and you'll see that it's not actually multiplied out. Okay. Right. Anything on 35? 35 part 3. 1 minus k. What does the language suggest? If it says show that, what does that mean?
Same both sides.
Well done, Phil. Means this side here must equal that side there. What does that k not equal to 0, not equal to minus 2 business mean again?
So just like to save the question from not existing. Huh?
Yeah, if the denominator, if it's 0, it'll be 1 over 0, and that means the question won't exist.
Yeah.
So it's just stating that k cannot be those two values. It's not going to influence what you're doing. What method would I use for this part here?
Same.
3 lines. 1 multiplied by 1 multiplied by k plus 2 is going to be just simply k plus 2. K multiplied by minus 1
Okay.
minus k, and finally underneath,
K bracket K plus 2.
and then on top k minus k
Cancel.
cancels, k into k equals 2. Right, you still have that on note. Good man. Okay, can I move on?
Yeah.
Good. I didn't do 38 yet, did I? I didn't get that far.
No.
You did.
Yeah, we have to
What? Do you have it for homework?
Yeah.
Yeah.
Okay. 38. Which part of 38 did I give you?
All the odds.
The odds, alright, the odds. Now,
Question 5.
yeah. Which ones would you like me to do now? This could be a case that you want me to do them all.
Yeah.
Yeah. Do them all.
Case you want me to do them all? Okay. Now, this one, alright. I take it back to a really simple fraction once again. I take it back to this system here. I'm going to write up in the corner. You have 5 over 12 plus 3 over 8. The way you would have done this in primary school would have been that you would have got the lowest common denominator and you would have said, look, I'm just going to turn everything into 24ths. Does that make sense?
Yeah.
The way I want you guys thinking of it is not like that anymore. This is the way I want you guys to be able to do them. I want you to factorise the 12 and the 8. Right? And when you factorise them, I like it that they both actually have a common factor. Do you know what I mean? Like, as in 8 is 4 multiplied by 2. See the 4 and the 4? See the way they're saying? Now, you're not multiplying them. What does that mean? If you're not multiplying them, I can't do this. Why can't I do that?
Wasn't bracket.
It's addition or subtraction. You can't do that. If it was like this, I could definitely do that because everything's been multiplied. Do you understand? It's 5 multiplied by 3. The 3 has been multiplied by everything on the top. It's 4 multiplied by 3 multiplied by another 4 multiplied by another 2. The 3 has been multiplied by everything on the bottom. That means I can cross off those 2 3's. Does that make sense? But I'm doing subtraction and division at the moment, which means I have to use the common denominator approach. Can't just cross off stuff randomly, okay? It's not going to happen. So everybody remember that? Plus or minus, no crossing off, too easy. Multiplication, division, you can cross them off. Yeah? Okay. Now, there we go. So back here. Now, what did I say the denominators like to do with each other?
They like they want what they don't have.
They want what they don't have. This one looks over, I have a 4, I have a 4, everybody's happy. That one has a 2, I don't have a 2, so I'll take a 2. That one looks over and goes, oh, that one has a 3, I want a 3, so 3 and 3. Then it goes 10 plus 9, gets us our 19 on top, would you agree with that?
Yeah.
And then the bottom is just 4 by 3 by, which is 24.
And it's the same on the bottom. You don't get the both at the bottom. It's just the same for both. Sort of.
Yeah, it's like this.
It's not 24. It's 24.
It's like this, right? 1/5 plus 3/5 is
4/5,
4/5. You didn't add the 5s.
Yeah.
So with subtraction and adding, they merge into one denominator. If that was multiplication, it'd be 5 by 5 to get 25. Yeah.
When it says like plus minus division between fractions, they always like cancel at the top, doesn't it?
What'd you say?
Like when you know like.
Oh, the plus and
yeah.
yeah. It's what I did with Rory a second ago. It's the 1 plus the 3 is 4.
Yeah.
The 5 and the 5 are
So it only cancels like the top.
exactly. Yeah. For addition and subtraction.
Yeah.
Yes. Okay. Okay, learning lots. Now, take this knowledge into what we have here. We do 5x minus 6. You break up the bottom and what does it become? I'm going to sort of
X minus 2, X plus 3.
x minus 2, x plus 3, and the other side is 3 into x plus 3. Now, what once looked very difficult now becomes a matter of what does that one not have? It doesn't have an x minus 2, does it? And that one doesn't have an x minus 2. Merge them together now to make one denominator, like you did with the fifths and the 24th, so it's x minus 2, x plus 3. And what happens to the top? It's just going to be 5x minus 6, yes?
Why could you put the x plus 3 in brackets as well? It's not being multiplied by what?
The x plus 3 and the x minus 2 are, which one? That one?
Yeah.
You can.
Now below like the x plus 3.
Here.
Yeah, why did you put that in brackets? Or what being multiplied by?
If I go back to the very top, yeah. Remember I had 12, yeah, and 12 turned into 4 multiplied by 3. That's the two then multiplied by each other.
Yeah.
So the x minus 2 and the x plus 3 there multiplied by each other. And over this side, the x minus 2 is being multiplied by the x plus 3 to make it exactly the same as that one there. Okay, it's always multiplied when we do this technique. Okay, and then on the top you have 5x minus 6 minus 3 by x minus 2 minus 3x plus 6. And then after that,
2x.
just 2x over x minus 2 and x plus 3. Everybody happy with that?
Yeah.
Okay. Do you want me to leave for a second? Is it?
For 2 seconds.
Yeah. Because we're going to fall behind. Now, okay, next one, okay, is this one here. It's the same thing, except there's 3 fractions instead of 2. Everybody alright with that? So what's going to happen here is we're going to fully factorise absolutely everything. So it's going to be 5 over 2x minus 3. What's the second one going to be? 3 divided by x into, and finally followed by minus 1 over x. Now, what's going to happen next, guys, is exactly what happened last time. What's going to happen with the denominators?
Give them x.
They want what they don't have. X goes here, x goes there. What's next?
2x minus 3.
And then, what happens when you add 3 fractions together? What happens to the denominators? They just become one denominator. And you don't add them or anything like that, you just put that as a denominator. So x into 2x minus 3. Now, I'm just going to multiply this out quickly, save myself a bit of time. You see what I did there? Just why you rewrite the full thing.
Yeah.
So 5x minus 2x, 3x, yeah, minus 3 plus 3. Now, here's a good one. Is there anything left to do? And I can get rid of the x's this time. Why? The x is being multiplied by the 3, which means it's being multiplied by everything on the top. This x is being multiplied by the 2x and the minus 3, which means it's being multiplied by everything on the bottom. The criteria for cancelling has been achieved, and you're left with 3 over 2x minus 3. Yes?
Just because you factorise the bottom part there, see the way it's like x bracket 2x minus 3.
Yeah.
Does that mean that that doesn't need the extra x there in the end? Sort of thing.
This x here?
Yeah. The
It's,
other way you were putting that in, you were.
it's like this, right? It's basically a fifth plus 2 fifths plus 7 fifths. Well, provided they're the same. Oh, sorry, that one already had an x.
Yeah.
Which means it was only lacking the 2x minus
Yeah.
3 to be
Oh,
exactly the
cool.
same as the other denominators. Is that what you're asking me?
Yeah, yeah. pretty much.
Okay, fair enough. 3 over 2x minus 3. Cool. You keeping tabs on what I'm doing? So it makes me making the video a lot quicker, yeah? This one here. This one's a sneaky one. Okay? So I'm going to show you another trick. This trick you need to learn off by heart. have it stored in the locker, ready to go. Everybody ready with this? Okay, here's what needs to happen, okay? Does everybody remember that 2 over 5 is the same thing as minus 2 over minus 5? Would you agree they're the same value?
Yes.
They are. If you divide minus by minus, it makes a plus. Let's try this again. 10 over 2 is the same thing as minus 10 divided by minus 2. Agree with that?
Yeah.
Oh, answers are 5, yeah? You can multiply the top and bottom of any fraction by minus 1 and it will work perfectly. If I was given a random fraction, okay, as an example, if I was given 1 over 3 minus x, everybody see that? This fraction is actually the same. Multiply top and bottom by minus 1, what happens? Multiply the top and bottom by minus 1.
X minus 3 over minus 1.
Yeah, you get minus 1 on the top, the minus x changes to a,
Plus
and the plus 3 changes to a.
minus 3.
So, in effect, these two fractions are actually they're the same thing, aren't they? So, therefore, you're always on the lookout for when the bottom is the minus version of the, two denominators. One of them has a minus version of the other one. Can anybody looking at question 5 see anything that might come in useful there? Alright, that's it, and that's learned off by heart. I recognise that one and that one, and I'm going, there's a trick here, okay? Here's my trick. X minus 1 stays the same. X minus 1 stays the same. This one is minus 1 over 1 minus x. Multiply the top and bottom by minus 1. It doesn't change the value. So therefore this will turn into plus 1 all over x minus 1. Anybody want to stop me there and have a question about it? We good?
No, you just put the X minus 1 over the
Now, this one has a denominator of
1.
1. It's jealous that it doesn't have a.
X minus 1.
So what we do is we will sort that problem out by saying x minus 1, and this here is x minus 1, and this is x minus 1, and then it wants another x minus 1 to counteract that one there. What happens when I add all 3 fractions together? What's the denominator going to be? No, I think there's a trick with this one. That's a 1, yeah? What's x minus 1 multiplied by x minus 1? I just assume you're going to be able to multiply them out, yeah? You're going to get x squared minus 2x plus 1. That's that part there, when you multiply it out. Then it's going to be another plus 1 at the end. Now, what are we looking at here?
X squared minus 2x plus 3.
Alright, now this is interesting. Sean's onto that, guys. Sean's telling me that that looks a bit like a reference number. He's going to try his hand at that. And so we're going to get x minus, is it x minus 3 and
1.
x plus 1. Unfortunately, it was a good guess, but it didn't actually yield anything we can cancel off, because x plus 1 is not the same as x minus 1, so we'll just leave it like that,
Yeah.
and we're done.
That was that answer.
Yes. Okay. Higgins.